Okay, why don't we get started? Yesterday we had a leaking gas valve in the lab. So I had to cancel yesterday's lab. And so because I canceled yesterday's lab, I'm canceling today's lab as well. So you're going to be turning in lab 15 for lab 15 and 16. Okay. I mean, it's titration, so it serves a purpose. Okay. I will, yeah.
Do you want to do that as well as like with the lab too? Or do you just want us to like leave about 15? I don't know. Like we did about 16. Do you want us to turn it in?
Well, if you look on the assignments, the assignments is 15 and 16. So just turn in lab 15 for that assignment. And then do a conclusion and all that good stuff.
Did lab 17, right? Because on grades they showed one of my as missing.
Which one was 17? Yeah, leave the rock there.
It's on gas laws.
Oh, yeah. Don't do 17.
Okay.
We didn't do any gas laws, so. Okay, so we're going to start on acids and bases today. Now, you've already been introduced a tiny bit for lab 15. Talking about titrations, I'm going to talk about that again today. Now, acids and bases are solutions. That's why it's included in the solution first. So your test on Friday is going to be 50% stoichiometry, 50% solution. Now that's going to include acids and bases. Looking at solutions starting from concentrated liquid, also drying liquid. Now, if you go to files on Canvas, I've got some practice worksheets for you. Plus, if you go to modules, you'll see the textbook problems that will fill in that as well. Okay, so let's talk about what is an acid, what is a base. Now, acids and bases are kind of opposites, and I'll show you why people talk about that. Okay, so what is an acid? The simplest definition of an acid is a compound that will dissociate an H+ cation. If it doesn't dissociate, it's not an acid, period. So if there's an H present, there's a possibility it could be an acid, but it has to dissociate. There are strong acids and there are weak acids. There are 7 strong acids. These are the 3 most common. And you run across these over the semester. There's hydrochloric acid, sulfuric acid, nitric acid. Those are the 3 most common. And we haven't used nitric acid in here much, but it's a very commonly used acid. Most of the time we use HCl. It's inexpensive and it's a strong acid. It works pretty well. Okay, now contrasted to that strong acid is a weak acid. Weak acid, one other thing on strong acids, they totally dissociate. In other words, that H+ comes off the original molecule. So there's none left. Okay, so there's an arrow here, and that arrow is a one-way arrow only. So there is none of this left if it's a strong acid. It's all to the right here. Now, weak acid, only a little bit comes off. Most acids in the world are weak acids. There's only 7 out of probably, 500,000 weak acids, or even 1,000,000. There's a whole bunch of weak acids. Citric acid's weak acid. If you look in the Krebs cycle, there's about 5 weak acids in there. One of them citric acid. There's a whole bunch of organic acids that are weak acids. So those come off in varying degrees from 0 to 100%. So it could be 1% disassociates or 98% disassociates. But unless it's 100%, it's not a strong acid. Okay? And then there are non-acids. These have hydrogens, but they don't come off. So they're not an acid. So there's 3 situations. Strong, 100% come off, nothing comes off, or the ones in the middle are called weak acids. Now, as a contrast to an acid, we have something called a base. And a base disassociates a hydroxide anion, OH minus. So acids do H plus, bases do OH minus. Yeah. That guy? Okay, and like acids, we have strong bases and weak bases. There are 2 main strong bases you're going to be associated with when you go in here and also in your next chemistry class, and that's sodium hydroxide, potassium hydroxide. Those are strong acids. That means they disassociate the OH minus 100%. Now, then let's talk about weak bases. Weak bases are just like weak acids. They disassociate less than 100%. And most bases are weak bases. And then there are non-bases. Okay, because it has an OH group, it may be base and it may not be. For example, glucose. This is what glucose looks like. Glucose has got a lot of OH groups. Ethanol, drinking alcohol, it's got an OH group. Neither one of these is a base because the OH doesn't come off. All right, so same thing here. We have 3 situations. Strong base, 100% comes off. Not a base, the OH doesn't come off at all. And then the weak bases are in the middle. Okay, so let's look at a very ubiquitous compound. Water. Water's got an H, water's got an OH. And water is both a weak acid and a weak base. Very weak, but it is an acid and a base. Combined together. It's very unique. Our world is extremely unique because of the characteristics of water. Our environment is shaped by the uniqueness of water. Ice floats because water is unique. Most solids are more dense than their liquid counterparts, not water. The solid is less dense, that's why it floats. There are only 6 or 7 compounds in the world that do this. And what's wild is water is the most common thing on the earth. So we have H and OH. So instead of writing water like H2O, we're going to write it H-OH. Okay, so we have the OH part, which is the basic part, the H is the acid part. So we have chemical equation here. Now, because it's a weak acid and a weak base, you're gonna have a little bit of H come off and a little bit of OH come off. Not 100%, just a tiny bit. Okay, so when we draw the arrows, instead of one-way arrow, we're gonna have a two-way arrow. And notice there's a little arrow on the top, a big arrow on the bottom. Big arrow means that most of it is on the left, not the right side of the equation. If we measure the concentration of hydrogen ions, it's going to be 10 to the minus 7 molarity. That's very, very weak. And because we have this is a balanced equation, we have a 1-to-1 ratio. That means whatever the concentration of H is, that's the same concentration as OH. So that's hence concentration of the OH is going to be 10 to the minus 7 molarity also. Now, this is what happens when we have a neutralization reaction. Neutralization is going to be when we put an acid and a base together. What happens is, because the acid will kick off an H plus, the base will kick off an OH minus, they'll immediately form water. And that's what drives the reaction, is the formation of this water. So if we take, for example, hydrochloric acid, put hydrochloric acid and sodium hydroxide together, we're going to end up with water. And what's left over, and they call that salt. What's left over is a sodium cation and a chlorine anion. Sodium chloride, common table salt. Now, if we have something called a monoprotic acid, mono means one, protic means proton. So if we have a monoprotic acid, one H plus comes off. If we have a diprotic, acid, two protons come off. So you're not going to be working with diprotic acids till you get your next chemistry class. In this class, we're doing monoprotic only. So sulfuric acid is an example of a diprotic acid. So when you balance the equation for that dissociation, you have whatever the concentration of this is, you get twice as much H plus. So if you have a 1 molar solution of sulfuric acid, you're going to end up with a 2 molar solution of H plus and a 1 molar solution of the sulfate. With a strong monoprotic acid like hydrochloric acid, if you know the concentration of this, that's the same concentration automatically of H and Cl minus. Because remember, there's no HCl molecule. It's H and Cl separate. And these would be aqueous in an aqueous environment, water. Remember yesterday, I said square brackets is the same as molarity. So if the concentration of hydrochloric acid is 2.65, that means the hydrogen ion concentration is also 2.65. So if we know the concentration of that, we automatically know concentration of that. Because it automatically goes 100% to the H and HC and the Cl side. Okay, so what would a problem look like? And by the way, who's heard of pH? Okay, pretty much all of you. If you haven't heard of it before, I'd be surprised. pH is a measurement of, and that's lowercase p, uppercase H. It's a measurement of hydrogen ion concentration. However, pH is weird. The definition of pH is the negative logarithm of the hydrogen ion concentration. The negative logarithm. Because it's the negative logarithm, when the pH goes down, the concentration gets more concentrated. So low pH is stronger than high pH. We also have pOH. That's okay. That's the measurement of OH concentration. And that's also the negative logarithm of the OH. So a pH of 7 is considered neutral. So we want our water supply to be slightly above 7, like 7.05. If it's on the below 7, it's acidic. Flint, Michigan's water was 6.2 pH, means it was acidic, and that acid was leaching out lead from the pipes. That's why they want domestic water supplies on the basic side above 7. And interestingly, our bodies, who's had A and P in here? Anyone? What's our physiological pH? Remember? Huh?
I think I got you.
It's 7.04. So our bodies are slightly alkaline or slightly basic. So all of our enzymes are designed, except for a few exceptions, all of them are designed to run in a physiological 7.0 pH environment. So when it's not 7.04, the enzyme doesn't work as well. Now your stomach has an enzyme called protease. Proteases hydrolyze protein. They dissolve protein. So if you have stomach acid, what's the first thing you do? Tums, which is an antacid. So what an antacid does in your stomach is it neutralizes your acid. Well, your protease needs acid to work. So by taking an antacid, like a Tums, your protease enzymes don't digest meat very well, or protein in general. So what happens is it gets dumped in your small intestine, which is not pH 2 anymore. So your proteases that were in your stomach don't work anymore. So that old protein just kind of continues on down. So keep that in mind when you have heartburn. Is a try not to take an antacid. I know it's uncomfortable. I go through, if I eat too much, I have heartburn. If I drink too much, I have heartburn, especially red wine. If I drink too much red wine or white wine or brand. So consuming alcohol will create heartburn. And then taking an antacid will just not kill, but create an environment that your enzyme don't work very well. So enzymes require two things: temperature and pH. They're designed to work in those two environments. So when that environment is not there, the pH or the enzyme doesn't work as well. In fact, I just finished a lab over at Sac City. I teach organic chemistry over there. We just finished a lab on lactase. And we've modified the temperature and looked at the activity of lactase. We modified pH, looked at the activity, and the activity falls off each time. So anyway, we like to see pH 7. Now, you've got these fads on the market called alkaline water. There's a pH of 9. If you consume alkaline water, guess what happens when it hits your stomach? Your fancy water gets neutralized because in your stomach is acid. Alkaline water has sodium hydroxide in it. Sodium hydroxide and HCl, which is in your stomach, form water and salt. So keep that in mind if you buy alkaline water. Okay. All right. So we're not going to do any calculations on pH in your 2A and your 1A class or your 3A class. You will be doing logarithmic calculations on hydrogen ion concentration and all that stuff. Okay, but not in here. I just want you to be introduced to pH. It's a very important concept in anatomy, physiology, and in organic chemistry, biochemistry. It's just universal. So make sure your calculators have an LOG function on it. You're going to need it for your next class. Most scientific calculators have it on there. All right, so let's look at a problem. Okay, so what's the hydrogen ion concentration of HCl? There are 23.4 grams of HCl and 2.34 liters of water. This is just like the dry calculations we did yesterday. Now, you have to remember this reaction. HCl is one of the strong acids. So we can calculate the moles of HCl, and because we know it's a strong acid, that means we know the moles of hydrogen ions, 1-to-1. We also know the moles of, oops, I did a mistake here. We also know the moles of the chlorine atom, or ion, which is chloride. Okay, so we know the moles of that, we know the moles of that, we know the moles of that, because it's a 1-to-1-to-1 ratio. So the first thing we need to do is calculate moles of HCl. Okay, so we have Okay, so we're starting with 23.4 grams of HCl. The molar mass of HCl is 36.46 from the periodic table. Now that gives us moles of hydrochloric acid. We know what moles of hydrochloric acid. We want moles of hydrogen ion. And that's a 1-to-1 ratio. So that converts it over to moles of H plus. Now the problem asked for the concentration. Concentration, remember from yesterday, is moles per liter. We got the moles part now, we've got the liters part. So if we do a quick calculation here. Okay, so everyone see how we got the constant or the number of moles of H plus comes from the moles of HCl. And we know it's a 1-to-1 ratio, a molar ratio. Now we have, this is moles of H plus now. Moles per liter. We're looking at 0.743 molarity. Okay, so the kingpin on this is to calculate the moles of HCl first. And that automatically means you calculate the moles of hydrogen ion. Is everyone okay with that? We want concentration, that's moles per liter. We can do a very similar calculation if we're looking at a basic environment like this guy here. Okay, so let's do one with a base. What's the hydrogen, what is the hydroxide ion concentration of sodium hydroxide? There are 23.4 grams of sodium hydroxide, 2.3, same thing. Okay. So number one is calculate moles. When we disassociate OH from sodium hydroxide, we have a reaction equation of 1-to-1. So it's one of these or one of those. So once we find the moles of sodium hydroxide, we'll automatically find the moles of hydroxide ion. Okay, so we're looking at and it's 40. Okay, so that gives us moles of sodium hydroxide. And then the ratio between sodium hydroxide and hydroxide is 1:1. So this will automatically calculate moles of hydroxide ion. My calculator is dying here. Now we have the moles of hydroxide ion. I'm going to put that over the volume, which is 234. Point 25. What about sig figs? Is that the correct number of sig figs? How many sig figs do we have here? Every one of this is 3 sig figs, so that's 2. So we need to make sure it's 3 sig figs. So that's basically calculating concentration of hydrogen ion and hydroxide ion, knowing the moles of either acid or moles of base we've got. Okay, so what's interesting about a neutralization reaction? Let's say we have we take hydrochloric acid, sodium hydroxide, throw it together, you get a neutralization reaction. Now the question is, we also have another situation come up here with a neutralization reaction. Because if we don't have exactly the number of moles of HCl equaling the number of moles of sodium hydroxide, we're going to have leftovers. So if let's say I have 1 mole of HCl, 2 moles of sodium hydroxide. How many moles of water have I just created? Right, 1. And if I created 1 mole of water, how much of the sodium hydroxide did I need to create that 1 mole of water? 1, exactly. So guess what? We have leftover hydroxide ions. And we have 1 mole left over. Because we only needed 1 mole because the ratio between HCl and sodium hydroxide is 1:1. And we have a situation here where whenever we have a neutralization reaction, The H's and OH's have to be exactly the same, otherwise there's excess of one or the other. So you open up your car hood, look at your battery, it's got this white powder all over it. So they always, you go onto YouTube and it says to take some baking soda to neutralize the white powder. And when you do that, it all bubbles up and all this stuff. But you have to use an excess of baking soda to make sure you got all that white acid dissolved. If you don't add enough, it's still going to be there. So you've got to get an excess of one or the other to neutralize the H pluses on that battery. That's why when you sometimes get a new battery installed, they'll put grease on the new terminals to keep that white acidic powder from forming. Depends on where you get your batteries installed. If you go to a car parts place, they will install it for you. They'll go screw the terminals on and close your hood, and they'll put nothing else on. It depends on where you get your battery, new battery. Okay, so if we have more base, like in this case, than acid, we're going to get leftover base. We have more acid than base, and we'll have leftover acid. That's the concept of neutralization. Okay, so all right, if we mix so much hydrochloric acid, so much sodium hydroxide together, what is going to be left over? Okay, so we have so we have 1.23 liters of HCl, 0.56 liters of sodium hydroxide. We dump these two together. What's our new volume? How do we get that? Well, we have 1.23 liters dumping into 0.566 liters. So together we have to add them together. Add them together. All right. We could use my phone.
You want to calculate it?
Yeah. Give us Carol. Great about rechargeable batteries is you can recharge them and not have to buy batteries. What's bad about it is you do have to recharge them. Okay, so we have 1.23 plus 0.566. We're looking at new volume is 1796 liters. Okay, that's the first step. Let's find out what our volume is. Next step is to figure out how many moles of HCl we have, how many moles of sodium hydroxide we have. So we're looking at Okay, remember, concentration times volume equals moles. Okay, so we have 2.88 moles of HCl and 2.88 moles of H plus. Because remember, the HCl moles equals the H moles. Next step. Act like the moles of sodium hydroxide. Same way. .45. Okay, so we have 288 moles of H plus, 195 moles of hydroxide. So what's going to happen when we dump these two together? We have a neutralization reaction. We combine an acid and a base together, we create water. So how much water are we going to create? Well, which is less, the acid or the base? Moles wise. Well, the base is 1.95, the acid is 2.88. Which is greater? The H's, right? Okay. When we create water, it's a 1-to-1 relationship. So if we have 195 moles of OH, it's going to create water with 1.95 moles of H plus. Okay, so we're going to use all of the OH and only part of the H. Because this is a 1-to-1-to-1, that means we're going to create 195 moles of water. Plus, what do we have left over? H. And how many moles of that do we have left over? Well, that's what? 93 moles. Excess H plus. Now the water doesn't contribute to the concentration of H plus. That's already used up. So now we have in our solution here, was it 093? Oops. Okay, we have 0.93 moles of H plus in 1.76 liters of water. What's the concentration of H plus? Well, we have Okay, since it's 293 is too sig figs, the answer is gonna be 0.50, 0.52 molarity of, that's the H plus. And then if this was 1A, we convert it to pH. But right now, we're gonna leave it as moles per liter. So that's a typical neutralization problem. You've got so much acid, so much base, and you're gonna have less of one of the two unless it's perfect 1-to-1. Usually it's not. You're gonna dump an acid into base, and what's gonna be left over is how many moles of what hasn't been neutralized. So if we have more H, then we're gonna have H left over. If we have more OH, we're gonna have OH left over. And you have a total combined liters of volume, adding them together, and that'll give you moles per liter. All right, now that's as complicated as we're gonna get in this class, a neutralization problem like this.
Is that gonna be on the test too?
I haven't made the test yet. It's gonna be on the test as extra credit. All right, so everyone hear that? It'll be on the test Friday, but it'll be extra credit. Okay, now what I'm gonna do is, are there any questions about that problem? Okay, so let's look at. A titration problem. Okay, last couple weeks ago, we did our sodium hydroxide standardization, which was titration. So basically, we had acid at the bottom, the KHP, and then we had sodium hydroxide up above. Then we dropped the sodium hydroxide into the dissolved KHP acid, so it reached the endpoint, which is that nice pink color. We can use that information to determine the acid concentration or the sodium hydroxide concentration, whichever is unknown. Basically, we want to neutralize the acid below with the base above. We don't want any excess H's. We don't want any excess OH's. So we used an indicator to tell us when that ratio of moles of this equals moles of that is obtained. Okay, so we're going to use an indicator. Indicator will tell us that. That's called an endpoint. Now, in 1A and 2A, they're not going to call it an endpoint, they're going to call it an equivalence point. And they're this. And as far as the indicators you use in lab, they're one and the same points. Sometimes they're not, but as far as our class is concerned, your 1A, your 2A, or 3A, it's going to be the same. So there we're going to determine the number of moles of base used to equalize the number of moles of acid below in the titration. So moles of acid equals MV. moles of base is equal to MV. So our burette will give us milliliters of base, unknown concentration. Our acid is a solid acid, so we have grams of KHP acid, and we can calculate concentration of that in terms of moles. So the acid KHP, we know grams. That gets us to moles through the molar mass. With the base, the sodium hydroxide, we know the volume. But we don't know the concentration. And the whole exercise in lab 15 is to calculate the concentration of our sodium hydroxide base. So we're not doing lab 16. So I want you to focus on calculating the concentration of your sodium hydroxide. So the goal of lab 15 is to calculate that concentration using moles of KHP against moles of sodium hydroxide. The volume of sodium hydroxide comes from the milliliters on your burette. We know how many grams of KHP we used. We calculate via the molar mass how many moles of KHP. It'll be the same at the endpoint only. If you go past it, you're gonna end up with excess sodium hydroxide. If you do it too early, you'll have excess H plus. You want to do it right at the endpoint. You need to stop, and that'll give you concentration of your sodium hydroxide. We are officially done with the content of Chem A. All right, so Friday, you're gonna have stoichiometry problems. I want you to really make sure you know stoichiometry inside and out. That'll include some conversion problems, like how many atoms of hydrogen are in 5 grams of water, something like that. And that's it. Then you'll have an actual reaction as well. Very similar to test 2. And I'm doubling down on that because that's one of the weak areas of the typical 1A student, or the typical 3A, or the typical 2A student. And then solutions, we get into moles again. So it'll be solution problems, similar to the ones that I showed you yesterday on the Canvas. If we zoom over to Canvas again here. We go to Files. We go to Unit 5, Solutions and Acids and Bases. You have a number of molarity worksheets, making dilutions. Those are all good worksheets with answers. Some of them have setups, some of them don't. I did not create those, I found those. Some of them have just the answers, some of them have a setup as well. But definitely those are candidate questions for Friday. Also look over test 2. That'll be graded today. I think I'll have to have a boatload of coffee today, but anyway, it'll be graded today. If you want your test graded earlier, stay after class and grade it right here in front of you. Yeah. You would have if we didn't have a gas leak. We had a gas leak, so I had to cancel yesterday's lab. 15 only, yeah. Right. Yeah.
How big, for the final, how big do you want us to put it card?
Oh, let's do half page front and back.
Like a standard piece of paper?
Yeah. 8.5 by 11. So either one side of 8.5 by 11 or both sides of a half a page.
Okay.
Both sides of the half of those. Or once, yeah. All right, so any questions? You guys been a good class, really fun to work with you guys. Now, next semester, I'm teaching Chem A again. I'll either be in 111 or AT3. Theoretically, it's gonna be AT3 if they do the transfer. Feel free to come into my class. If you want to sit down while I'm lecturing on any of these topics we went over today, feel free to. Just come in. Or after lecture, you can ask me questions. Come in the lab. Feel free to. Don't be shy about that. You're more than welcome you to do that. As we get into 2A, it's going to be, you guys will be super prepared for 2A. And mostly prepared for 1A. 1A is significantly harder than 2A. Just FYI. It's just the nature of the beast. And it's a beast. All right. That is it. Huh? It should be a week from today. Yeah, because I always do it, week after, and theoretically, we're supposed to have 16 today.
Look at all these poor calculators.
Yeah, they're all,
Oh my god.
could you give this one back?
Yeah. Can you grade my exam?
Yeah.
I'm too nervous. I keep checking it like every hour and I'm like, I just need to ask him. I already know I made a mistake on the first one. I made it too long. I was turned to this something I should have made it us. Mistake, but that's all right.
Okay. Kathleen, what's your last name?
Anderson
Oh, you're right up top. In the other class.
and other, yeah.
I learned something called a blueprint, where you can merge two classes together. Two sections
Does it
together.
work?
I don't know, I just heard about it.
Oh,
I'm gonna try it for the spring.
yeah, that might be easier.
Well, normally I do something called crosslink. Well, there's new rules out, that's not legal. So I can't do it anymore. I do it in. Anyways. The weird thing is, at Sac City,
Mhm.
where is just,
I think it's further up. There it is.
um.
I know, I'm like staring at like everyone's score.
Yeah.
Uh,
Do you have a quick question?
Yeah, just real quick. I turned in a couple of labs late. Do you want me to email you?
Yeah.
Okay.
Because it doesn't tell me when you submit all that. I mean, when I find your stuff, it'll say late, but it doesn't tell me it's not graded yet. So definitely send me,
Okay, perfect. Thank you very much.
and it's better to try late than not at all.
Yeah, of course.
Yeah, because you won't get any points.
Yeah. Thank you.
Sure.
To get us through the next two classes. Are you guys on Discord, on the chain? I don't know how to use it. Yeah. Sure, let me see.
I couldn't figure it out.
Yeah, it's not easy. And I'm old and I don't know. Technology that well. It wasn't easy.
I can't get it, just do anything like.
All right, well, I'm not an athlete, so it doesn't let me add you guys.
So you got the app?
I have a question. There was like one or two labs that I just like didn't turn them in, but I literally I have all the calculations done for grant. If I turn them in now, can I still get credit for them?
Partial credit. yeah.
Partial credit? How much credit would that be?
Depends how late it is.
Okay.
you know. But sometimes it'll say it's late and if it's like 2 minutes late.
Mhm.
So I just,
Okay,
because the color on canvas changes.
Okay.
right? Goes from a black, or a white background to a, yellow background, when it's late. And then it tells you how late it is. So if it's an hour later, I don't worry about it. But if it's days or weeks late, well, then you're gonna.
okay. I wanted to let you know, reason for that was I was not in the country for a few weeks. So if I could send you those dates, I could send you like my flight details when I wasn't here. I had to go to India for medical reasons. So if I could send you those dates, then could that give me more credit?
Yeah.
Thank you. I appreciate it. That was quite significant. Thank you.
Sure.
Okay.
So as usual, you blazed on.
I know I did one of these wrong, or whatever,
No, you
is that my writing? That's not.
That's my key. You didn't do anything wrong. You got a
No,
one,
but
you got a
the,
100.
wasn't it 1.30 times 10⁻⁻25 or whatever the heck,
For which one?
for like the first? It was the second one, I think. It was the Avogadros. I did like 1.304, I think. I'm
Yeah,
trying to-
that's the same number I got.
Oh, okay, so I did okay.
You're all right. Anyway. Yeah, so you did even
All
better,
right, so-
even better than your last one.
Oh my gosh, okay, so I think I don't have to do the poster.
Correct.
I think as
Do
long
not-
as I practice my
Do not
stoic,
do the posting
okay.
because.
I
it'll be-
practiced it.
Well, the posting, you would be wasting your time.
Oh, right, you can do better, yeah, okay. I think I'll focus on yesterday and today's equations more.
Yeah, and stoic amateur you have down pat. so-
Okay. Okay, you know, and I'll be focusing.
I tried to already yesterday.
But do you have the answer?
Are you guys thinking of the all?
Yeah, I don't want you to do this.
Eventually, okay, even if you have different classes. you just don't have
I want you to do to. This guy here, I want you to do these. And these will be practicing what we did yesterday and today. Like, for example, okay, take care. Either. Yeah, mold and all that junk. Okay, glad you asked.
Just wanna make sure, thank you.
Sure.
I'm gonna go and start on some of these, this is the fill out that really clear restrictions. So for this one, how do I get started? So it tells you the percent of the load concentration and the volume, I know that. This is the volume. Then we need to concentrate, or is this the concentration?
Okay, so this is the dilute one.
Okay, so
This is- That's the concentrated one.
yeah, so that's on this, so.
And then this is the diluted volume as well.
Dilute that.
So what you don't know is L concentrated.
The concentration.
Yeah, so I don't like to use 1 and 2, I like to use concentrate dilute. So like this, it just doesn't tell you anything.
Exactly.
Okay, so you know everything except that.
Right, so I know there's two things. There's two things.
Well, I mean, the sulfur V, so V concentrated is C dilute, V dilute over C concentrated. C concentrated is gonna be 6,
Right,
so it's gonna be, this is gonna be 1 more. And then 500, yeah.
I'm gonna do that, and then that's my answer. I don't give him much water or anything like that, or.
Oh,
That's. that's
yeah.
something else.
So what you're gonna do, you're gonna end up, it's gonna be like 8.3 mils.
Okay.
And then you're gonna take 500 minus that, and I love your water.
Gotcha. And that would be the same for this. So they gave me-
Have I made it that time?
This is different. Okay, so here you have. Oh, that's awesome.
Mhm.
Let me do one thing here first. When I get this, stop the recording.
Do you hear all the answers?